A single overheated axle bearing. That's all it took. In the early 1900s, one wooden boxcar caught fire. It was reduced to ash in under 5 minutes, and it took the rest of the train with it. At the time, nearly 45,000 wooden boxcars formed the backbone of American freight. They cost as little as $300 to build, could be repaired overnight, and had ruled the rails for almost a century. So why did railroads ban them from service forever? The answer is a hidden chapter of industrial history, and it begins with the very thing that made wood so irresistible. Timber meant opportunity. In the golden age of American railroads, forests stretched for hundreds of miles along the tracks, and sawmills fed boxcar factories with a constant stream of pine and oak. The price told the story. Seasoned pine cost just 7 cents a board foot, while steel sheet demanded nearly triple the price. For the railroad companies, the math was simple. A wooden boxcar could be built for around $300, a fraction of the cost of a steel car, which often soared past $1,000. This bargain shaped everything. Car building shops lined the major rail corridors, each one packed with skilled carpenters who could assemble a boxcar from scratch or patch up a damaged one in a single shift. The tools were hammers and saws, not welding torches. A cracked plank or splintered door didn't sideline a car for weeks. Instead, a fresh board from the lumber pile and a few iron spikes sent it back onto the rails by the next day. In the Midwest, Chicago, Milwaukee, and St. Paul's shop kept a standing order for standard-length planks, ready to swap out broken sides at a moment's notice. Every hour saved on repairs meant more freight moved, more revenue earned. The network of repair shops and lumber suppliers formed a living artery for the industry. Timber yards in St. Louis and Louisville shipped milled boards straight to the car shops, while smaller depots from Memphis to Sacramento stocked the parts needed to keep a fleet of 45,000 cars rolling. The abundance of wood and the speed of repair let railroads run larger fleets with less downtime. Carpenters became the unsung heroes of the system, their hands keeping the gears of commerce moving. For decades, wood's low cost and quick fixability seemed unassailable. The boxcar's wooden frame was not just a product of necessity, but of economic genius, a solution that turned the vast forests of America into rolling freight empires. Yet beneath this efficiency, a question lingered. Could a material chosen for its price and convenience withstand the mounting pressures of a nation hurtling toward industrial might? The answer would be revealed not in the shops, but on the rails themselves, as the demands of heavier loads and faster trains began to test the limits of wood's promise. Shop foremen began to notice a troubling pattern. As the years passed and freight loads grew heavier, the old wooden frames started to betray their limits. In the 1860s, a typical boxcar axle carried about 20 tons. By 1910, that figure had climbed to 31 tons, an astonishing leap for a structure built on mortise and tenon joints and iron bolts. The very joinery that once made repairs so quick now became a weakness. Under the strain of industrial cargo, including steel rails, coal, and machinery, these joints flexed and bent, transferring loads in unpredictable ways. Carpenters reported hairline cracks radiating from bolt holes and side sills that bowed under pressure. A single overloaded joint could trigger a silent chain reaction. As one timber failed, its burden shifted to the next, multiplying the stress until the entire side panel threatened to collapse. Railroad manuals of the era warned that a wooden beam interrupted by a joint could only bear a fraction of the force handled by a continuous piece. Field tests confirmed it. Mortise and tenon connections, the backbone of boxcar construction, provided less than half the bending strength of solid timber. When a train braked hard or hit a rough patch of track, the weakest link gave way first, and the damage spread quickly. Shop logs from the Pennsylvania Railroad in 1908 mention a rash of repairs where side frames buckled under concentrated axle loads, sometimes crushing the goods inside and forcing emergency stops. As axle loads climbed past 30 tons, the ceiling of wooden construction became impossible to ignore. What had once been a workhorse now showed signs of progressive collapse. A domino effect where the failure of a single joint could doom the entire car. The warning signs were there, written in splintered beams and bowed floors. For every boxcar patched up in the shop, another rolled out onto the rails, carrying a hidden flaw, waiting for the next heavy load to reveal just how close the system ran to disaster. Every mile of track carried a hidden threat. Wooden boxcars, built for economy and speed, became rolling tinderboxes the moment they left the yard. The danger wasn't just in the wood itself, but in the brutal physics of steam-era railroading. Coal-fired locomotives spat glowing cinders that rained down on passing trains. A single ember could lodge in a crack or knot, smoldering unseen, until a gust of wind or a sudden jolt fanned it into flames. But the most insidious threat came from beneath, the hotbox. A hotbox started with a simple oversight. Bearings on the axles, packed with grease, would overheat if neglected, raising the temperature past 200 degrees Celsius. At that point, the iron journal scorched the wood around it, and the boxcar's side panel could burst into flames in minutes. Crews watched for smoke and the acrid smell of burning oil, but on a long freight run, vigilance slipped. In 1913, a Southern Pacific train near Bakersfield suffered just such a fate. A single overheated bearing set a 58-foot wooden boxcar ablaze. The fire leapt to two adjoining cars before the train could be stopped. The entire blaze lasted less than 12 minutes, leaving little more than a charred skeleton on the rails. Fire drills became routine, but they were often futile. Water tanks, sand buckets, and even blankets soaked in brine lined the caboose, yet the speed of combustion outpaced any effort to contain it. Once the flames caught the dry pine planking, the car's interior turned into an oven. Cargo, including cotton bales, flour sacks, and crates of canned fruit, fed the inferno. Temperatures inside could reach 600 degrees Celsius, hot enough to warp iron hardware and melt paint off the walls. A wooden boxcar, fully involved, could burn itself out in less than 15 minutes, blocking the line and endangering every train behind it. For the men who ran these trains, fire was a constant, living threat. Brakemen risked their lives, scrambling with axes to chop burning boards away from the rest of the consist. Engineers kept one eye on the rails and one on the smoke curling from the cars behind. Every journey was a gamble. The next hotbox, the next stray spark might turn a routine run into a disaster. The fire hazard was more than a technical flaw. It was a deadly reality that no amount of quick carpentry could fix. Collisions turned wooden boxcars into death traps. When a train slammed to a halt or two consists collided, the wooden frames were no match for the brutal force unleashed along the rails. Instead of crumpling in a controlled way, the ends of these cars would collapse inward, one car driving straight into the next. Railroaders called it telescoping. In a matter of seconds, the body of one boxcar could be forced inside its neighbor, crushing anything and anyone in the way. The timber shell, built for lightness and easy repair, simply disintegrated under the impact. Investigators from the Interstate Commerce Commission combed through wreckage after every major crash. Their reports painted a grim picture. From 1900 to 1930, telescoping accounted for 35% of all fatalities in mixed train collisions. The problem was simple physics. Wood, joined with mortise and tenon, or bolted scarf joints, could not absorb the kinetic energy of a moving train. Instead, the force traveled through the car's weakest points, shattering beams and sending splinters flying. In some cases, the impact drove the roof and sides of one car deep into the next, turning the interior into a coffin of broken planks and twisted iron. Survivors described the aftermath as chaos. Walls buckled, floors ripped up, daylight streaming through gaping holes. One Interstate Commerce Commission investigator wrote, "The forward car was found telescoped a full 8 feet into the next, the crew compartment obliterated. For those trapped inside, rescue was a race against time and splintered wreckage." The Grand Canyon wreck of 1922 stands as a haunting example. A derailment at speed sent 6 wooden boxcars into a telescoping chain reaction, crushing the crew compartment and killing nearly 24 people. The official report cited the failure of wooden joist connections and the inability of timber to withstand dynamic impact loads. No amount of carpentry skill could undo the devastation left by these collisions. The numbers told a stark truth. As trains grew heavier and faster, the old wooden boxcars became a liability that railroads could no longer ignore. Telescoping was not just a design flaw. It was a recurring catastrophe, one that demanded a new solution if the industry hoped to protect its workers and its cargo. Test benches in the early 20th century became the final courtroom for wooden boxcars. Engineers, armed with stopwatches and pressure gauges, staged crash simulations and load tests that stripped away any lingering romance about timber on the rails. The numbers they recorded were impossible to ignore. When subjected to controlled collisions, a standard wooden boxcar absorbed just 0.42 megajoules per meter of impact energy before structural failure, barely enough to keep its shape under a moderate jolt. Steel boxcars, in the same tests, managed 0.78 megajoules per meter. That difference was not just academic. In a real-world crash, it meant the steel car could take nearly twice the punishment before caving in, giving cargo and crew a fighting chance. The gulf widened further under heavy freight. Steel boxcars routinely carried loads that would have snapped a timber frame in half. By the 1920s, a steel car could bear almost 70 tons, double the safe limit for wood. Lifespan told a similar story. Wooden cars, battered by weather and strain, lasted about 10 years before they needed to be rebuilt or scrapped. Their steel replacements ran for 30, sometimes 40 years, with only routine maintenance. Survivability statistics from accident investigations painted a grim contrast. In telescoping collisions, steel boxcars offered a 35% higher chance of survival for anyone inside. The difference was visible in the aftermath. Wooden cars reduced to splinters, steel cars battered, but largely intact. Every new round of testing made it clearer that the old boxcars were a liability the industry could no longer afford. These revelations did not stay in the laboratory. Railroad executives and regulators pored over the crash test reports, the load charts, the grim photographs from disaster sites. The evidence stacked higher with each passing year, making it harder to justify keeping wooden cars in service. The performance gap was now a chasm, one that policy, and soon the law, would be forced to cross. Railroad yards in the 1910s buzzed with a new kind of urgency. Purchasing agents, once loyal to timber, started placing orders with Pullman Standard and American Car and Foundry for all steel boxcars by the hundreds. The shift wasn't just a matter of preference, it was a race. As accident reports and crash test data piled up, railroad managers faced mounting pressure to modernize their fleets before the next disaster struck. Steel production lines ramped up to meet the demand. Pullman Standard's Chicago Works, originally built for wooden car assembly, retooled with rivet guns and rolling presses. By 1914, they delivered the first all-steel boxcar fleets to the Pennsylvania Railroad and the New York Central. American Car and Foundry, already a major supplier, doubled its output between 1915 and 1918, shipping steel cars to lines stretching from the Great Lakes to the Gulf Coast. The numbers told their own story. In 1915, more than 10,000 steel boxcars rolled out of American factories, 10 times the output from just 5 years earlier. Railroads that had once relied on quick carpentry repairs now invested in heavier, longer-lasting steel equipment. The Santa Fe ordered a full fleet of steel boxcars for its transcontinental routes, while the Baltimore and Ohio replaced wooden cars on its coal trains, citing both safety and economics. Purchasing agents, caught between tradition and the hard evidence of disaster, became the architects of this industrial pivot, their ledgers filled with steel car invoices, and their correspondence with manufacturers grew urgent. The old comfort of timber gave way to a new calculation. Every wooden boxcar left in service was a risk that could no longer be justified. By the late 19-teens, the momentum was impossible to ignore. The industry's largest builders had staked their future on steel, and the nation's mainline fleets began to reflect that faith. The market's verdict was clear, but the final push would come not from the shops or the yards, but from the regulators preparing to step in. Official orders began to redraw the boundaries of American railroading. In 1915, the Interstate Commerce Commission issued a rule that would shape the fate of every boxcar in the country. Wooden cars, once the backbone of the fleet, could no longer be built for mainline service. But the real blow came through the concept of interchange, the system that allowed railroads to hand off freight cars across company lines and keep goods moving from coast to coast. Without interchange rights, a boxcar was trapped on its home rails, cut off from the national network. Throughout the 1920s and the 1930s, the Association of American Railroads tightened the screws. Each new set of standards raised the bar for what counted as a safe, modern car. In 1938, the Association of American Railroads adopted Plate F, a specification that called for all-steel construction and higher load ratings. Wooden boxcars, with their bolted joints and flammable planks, failed to qualify. The final deadline arrived in 1945. Any wooden boxcar still in interchange service would be barred from the rails. Enforcement was swift. Railroads scrambled to retire, scrap, or retrofit their aging fleets. Knowing that a single wooden car could now block an entire train from moving freely across the country. The era of wood was over, not by accident, but by the deliberate stroke of the regulator's pen. The ban on wooden boxcars sent shockwaves far beyond the rail yards. In timber towns like Mankato, the fallout was immediate and personal. Payroll records from 1947 show a 30% drop in lumber-related wages within 5 years. Hundreds of carpenters and mill workers suddenly found their skills obsolete. For decades, these workers had built and repaired boxcars by hand, their livelihoods tied to the rhythms of the railroads. Now, as steel took over, sawmills shuttered, and families faced hard choices: retrain for metalwork, move away, or watch their towns wither. Bankruptcies swept through smaller railroads that could not absorb the cost of retrofitting or replacing their fleets. Some lines, unable to afford new steel cars or the expensive upgrades required by regulators, simply ceased operations. The wooden boxcar's demise was not just a technical story, it was a human one, measured in lost jobs, empty main streets, and the fading echo of hammers in abandoned car shops. Yet a handful of wooden boxcars escaped the scrapyard. Museum curators in Pennsylvania and Wisconsin salvaged what they could, restoring less than 2,000 cars by 1955. These relics, preserved in quiet halls and on short tourist runs, became symbols of an era that vanished almost overnight. Former carpenters now volunteer as guides, sharing stories of the tools they once wielded and the communities that depended on them. In these living museums, the cost of progress is measured not only in steel and timber, but in memory. Steel boxcars now thunder across the continent, a testament to the price of progress. Safety regulations and industrial logic left wooden freight cars behind, once essential, now erased by their own fatal weaknesses. Today's railroads rest on the ashes of that gamble, lives traded for efficiency, Tradition surrendered to necessity. In every vanished boxcar, history warns, no technology is too trusted to escape disaster's shadow. What do you think we're overlooking today?